Hello students and welcome once again. And this session is going to be for the senior students, and this is for the A-level students. And the subject is of course mathematics. And in A-levels, in pure maths, you have a topic called modulus functions, okay? Modulus functions. Now, this is what I am going to start with, modulus functions. I am trying to make a series of videos on these modulus functions. So right from the beginning, right from the scrap, I want you to understand what is this modulus function, and slowly and gradually we'll be going more deeper and deeper into this concept. So first of all, what is a modulus function? Like any other function, modulus function is also a function which can be in general written as y is equal to f of x. And when x is written between two parallel lines this way, okay, this is read as absolute x or modulus of x. Modulus of x, okay, absolute value of x, okay, or modulus of x, and it's a function, right? And it is denoted by putting that variable between two parallel lines. So this is modulus of x, right? Same way, this is modulus of x plus 1, right? This is modulus of x minus 2. Okay. If you write y equal to, this is a function, y equal to modulus of x is a function. It is a function. If you write y equal to modulus of x plus 1, again it is a function. If you write y is equal to modulus of x minus 2, it is a function. Okay. So modulus function means any function of the type this is modulus of x, this is read as modulus of x, this is read as modulus of x minus 1, modulus of x plus 2, modulus of x upon 2, etc. These are called as modulus functions, right? And another alternative name for modulus function is something called absolute functions, okay? It is also known as absolute function. In some book they refer to as modulus function, in some books they refer to as absolute function. In most of the graphic calculators, okay, when you want to type in the function, okay, to see the graph of that function, you have to use this absolute function to type in, okay. So there you don't use modulus word, okay. So absolute is used. Mostly it is ABS and then bracket and then this one. So this is what is used in graphic calculators. Okay, fine. Now, if y is equal to f of x in general, and that f of x is say modulus of x, then this is a function. Now in function, you know, like any other function, you have a domain and you have a range. So x is the domain and y is the range, isn't it? And since it is a function, you can always plot a graph of that function. So when you happen to plot a graph of y is equal to f of x, y is equal to f of x in general, and in particular y is equal to modulus of x. So this is the function y is equal to modulus of x, or y is equal to absolute value of x. This function, if you try to plot a graph, you will get a graph passing through the origin and it will be V-shaped. Okay, so this is the kind of the graph which you will be able to see for this function modulus of x. Okay, so y is equal to modulus of x. The graph is as shown over here. It will have a vertex at origin, okay, and then you will have a straight line at 45 degree in the first quadrant. You'll have a straight line at 45 degree at the second quadrant. Okay, so in the first and the second quadrant, you will have these two arrows. Okay, so both together is representing the graph of y is equal to modulus of x. Okay, now let us try to move to the concept of this. Now this was just the upper meaning of what is a modulus function. Now actually, to understand the modulus function, we should first understand what is the meaning of absolute value. Okay, what is the meaning of absolute value, or what is the meaning of modulus value? Okay, now Imagine you have a number line like this. Okay, you have a 0 in the center, you have 1, 2, 3, 4, 5, etc., up to infinity. And on the left hand side, you have -1, -2, -3, -4, -5 up to minus infinity. So this is basically a number line, right? It is a number line. Now, when you say modulus of 0, let us not discuss this right now, modulus of 0, but understand that modulus of 0 is equal to 0, or absolute value of 0 is equal to 0. It is, you can take it for granted. Okay. Later on, you will come to know it's a very simple statement. You have to assume, or you have to consider absolute value of 0 as 0. Okay. Next is this particular thing is read as modulus of 1 is equal to 1. This is modulus of 2 is equal to 2. In general, modulus of n is equal to n. Okay. Now you can see that between these parallel lines, I have put integers like 1, 2, and in general n. Okay. Now modulus of -1 is also equal to 1. Modulus of -3 is equal to 3, and modulus of -n will be equal to n. Now these are some of the values, okay, the absolute values of certain numbers that I have given you, and it is true, it is fact. Okay. Now try to understand the meaning of this. The definition, by definition, what happens is, by definition, absolute value definition is this: absolute value of x, that is x placed between two parallel lines. Okay, so this is read as absolute value of x. So absolute value of x is equal to x if x is greater than equal to 0. Now when I talk about this x, this is here, this one x, okay, the one which is placed between the two parallel lines. Okay, so when this x which is placed between two parallel bars is greater than equal to 0. Now, greater than equal to 0 means either 0 or any positive integer. Okay, so it can be 0, 1, 2, 3, 4, 5, 6, blah blah blah. Okay, so when x is equal to 0 or greater than 0, then its absolute value will be equal to same value x. By this definition, absolute value of 0 should be 0, absolute value of 1 should be 1, absolute value of 2 should be 2, and absolute value of n should be n. By this definition, okay? Now there is another part to this definition that is written over here in the second line. Absolute value of x is equal to minus of x if this x, now this x is what? The x which is placed between the two parallel bars. If this particular x is less than 0 means negative, right? So if the x value is negative, or in other words, the x between these two bars is a negative integer, then its value will be negative of x. Now x is already negative over here, so it will be negative of negative x, which will be nothing but positive x. Got it? So by this definition, the second part of the definition, if you want to find out the modulus of -1 in this case, then it will be minus of -1, which is +1, right? So modulus of -1 will be +1, and you see it is positive. Same way, modulus of -3 will be minus of -3, which is 3, and modulus of -n will be minus of -n, which is n. Okay, so you can see that the modulus of any function has a value which is always positive, immaterial whether the number between the parallel bars, okay, this particular x, whether this is positive or negative. Okay, your final value of this modulus of x is always positive. Okay, so this you have to always bear in mind, you have to keep in your mind. Okay, so this way you can say that modulus of x is always positive, never negative. Understood? Modulus of 0 you have to take as 0. Okay, modulus of 1, it will be 1. Modulus of -2, it will be 2. Okay, so regardless of what is between the two parallel bars, that is modulus of positive value or negative value, okay, the final value, the outcome will be always positive. Okay, so this is known as the domain, okay, or you can say the modulus of this x value, and this is the value of that particular function. Okay, so modulus or absolute value of 1 will be 1 and absolute value of -2 will be 2. Is that clear? So this is one way of understanding the concept of absolute value or modulus value. Let us go to the next slide. Now, suppose somebody gives you a statement like this, and it is read as modulus of x is 5. Okay, it is read in this way. It is written in this way and it is read in this way. Okay, so modulus of x equal to 5 or modulus of x is 5. What is the meaning of this? Okay, now mathematically I told you what is the meaning of modulus of x equal to 5. Okay, now let me change the approach of making you understand the real meaning of this modulus of x. Okay, so modulus of x, this particular thing, is nothing but distance. I will write here. Modulus is indicating a distance from the 0. Okay, modulus is indicating a distance from the 0. Okay, of a number line or on a number line, right? Now this is the meaning of modulus of x. Now let us try to understand how we came to this conclusion. Now modulus of x equal to 5 means the x, whatever is between the two parallel bars, that you have to take. So x is written between the two parallel bars. So you can say x is at a distance of 5 from 0 on the number line. That is the meaning of it. So I have written here, in general, if modulus of x is equal to k, the meaning of this is, it means that x, because x is written between the two parallel bars, right? So x is a point at a distance of k from 0 on a number line. So modulus of x equal to 5 means from this 0 on the number line at a distance of 5 units, this is that point, say P, and over here also from 0 at a distance of 5 on the left hand side, okay, say that is a point Q. So this P as well as Q both are the distance of 5 from the point 0. Okay, say distance is a scalar quantity and you have to take distance always as positive. Distance you never take as negative. But this phi is representing that distance from 0 on the right hand side. Okay, and this minus phi is indicating distance from 0 on the left hand side. So from 0 at the center of the number line, if you go on the right hand side, okay, and if you go 5 units on the right hand side, whatever point you get, that will be one of the answer for this x. Okay, and same way if you go from 0 on the left hand side towards the negative numbers, okay, if you go 5 units on the left hand side, whatever you get there, okay, that is again the value of this x. So minus phi is that point. So phi and minus phi, these are the two values of this x. Okay, so mathematically if somebody says solve modulus of x equal to 5, your answer should be x equal to 5 or x equal to minus 5. X equal to 5 or x equal to, if you don't want to write or, you can write and also. Okay, x equal to 5 and x equal, it will be better to write and. Okay, x equal to 5 and x equal to minus 5, right? So by definition, you know that modulus of phi is equal to 5 and modulus of minus phi is also equal to 5. Okay, see, this was the definition. If modulus of x is equal to x if x is greater than 0. In this case, your x is 5, which is greater than 0. So the modulus will be that phi itself. here the modulus of x is equal to minus of x if x is less than 0. Now here you can see the x is minus 5, which is less than 0. It is negative. So the modulus value of this minus 5 will be minus of this minus 5. So it will be minus of minus 5, which will work out to positive 5. Is that clear? So modulus of minus 5 is equal to minus of minus 5, which works out to 5. Got it? So modulus of 5, okay, will be equal to 5 means that x will be equal to 5 and x will also be equal to minus 5, because both this value of x are indicating the same thing. What is that? It is indicating the distance from 0. Okay, distance from 0. And what is that distance? 5 units. Hope you are getting it. Okay. So in general, if you want to speak modulus of x equal to some value k, the meaning of this is x is equal to k and x is equal to minus k. Okay. I don't know why I've written or, should be and. Okay. X is equal to k and x is equal to minus k. Now, here's a tricky one. Modulus of x is equal to minus k. What is the meaning of this? Modulus of x is equal to minus k. What is the meaning of it? Okay. Now here, don't jump to any conclusion very fast and try to say that again, modulus of x equal to minus k means the distance of the distance from the 0 on the number line is minus k, or distance from the number line is k, but on the left hand side. No, that will be wrong. Okay. Modulus of any number is always positive, and if somebody tells you modulus of x is equal to minus k, that means it is negative. So you can always say that this is meaningless. This is meaningless. Why? Because modulus can never be negative. The answer is because absolute value of x cannot be negative. Okay, it will always be positive, right? So if somebody is telling you modulus of x is equal to minus k, you just tell him that your statement is not correct. It is incorrect. Let us move on to next slide. Okay. Now here in this slide, so far I was talking about modulus of x equal to 5, modulus of x equal to k. Okay. Now let us go into inequality. So this is inequality in modulus. The topic is inequality in modulus. Suppose somebody says that modulus of x is greater than 5. What is the meaning of that? Suppose somebody says modulus of x is less than 3. Then what is the meaning of that? If somebody says modulus of x is greater than or equal to 7, what is the meaning of that? And if somebody says modulus of x is less than equal to 2, then what is the meaning of that? Okay, so these all 4 examples are of inequalities. Now there is no equal to sign, there is inequality sign. This is greater than, this is less than, this is greater than equal to, this is less than equal to. Okay, so let us try to understand how to find out the meaning of this. Let us go for this first one, modulus of x greater than 5. Now modulus of x greater than 5, the meaning of this is you have to come to this. Try to understand the meaning in the form of this statement. Modulus of x greater than 5 means that x, now what is this x? Whatever is written between the two parallel lines. Now in this case, between the two parallel lines you have x. Now why I am telling you this? Because in future, very soon, you will be coming across modulus of 2x greater than 5, something like this. Then in this case, what you have to interpret it as 2x is a distance more than 5 from 0. Okay. Right now it is modulus of x greater than 5. So whatever you find between the two parallel bars, that is x, you pick up that and write over here. So x is a distance. X is a distance more than 5 from 0. Okay. So this is the meaning of it. Now, if I want to show this on the number line, what I'll do, you see this number line? There's a 0 at the center. and there's a 5 over here, there's a minus 5 over here. Now this x is a distance which is more than 5 from 0. So can you see this is 0, this is 5 units on the right hand side, and all these distances, more than 5. All these values the x can take. Okay, this x can take all these values. Okay, this x can take all these values. Okay, so your x will be greater than 5. But remember, this phi is not included. It will not be equal to 5. It will be greater than 5. X will not be equal to 5. Right? So it will be any distance greater than 5. And another meaning is x will also be a distance which is less than minus 5. Can you see over here on the right left hand side you have a minus 5. So this distance, okay, on the left hand side, which I have shown by arrow, this distance is also nothing but the same thing. So this is x less than minus 5. Again here x is not equal to minus 5. Okay, so this x is not equal to 5 or minus 5, that I am not taking. But any distance greater than 5 and any distance less than minus 5 will be the answer for this solution. So modulus of x greater than 5, the meaning is always x is greater than 5 or x is less than minus 5. This is the meaning of it. Okay. Now this I have shown on the number line this way. This can be written in this way also. This is known as interval form. See what I have written in the round bracket. I have written, this is round bracket, minus 5. No, this I cannot write. I'm sorry. This I cannot write this way. I cannot write it in the interval form. I can write it only this way. X greater than 5. Okay. X greater than 5 and x less than minus 5. Okay. Or in interval form, if you want to write, you can write x greater than 5. So 5 to infinity and x minus infinity to minus 5. Okay. And the union of these two. Okay. So this way you can write in the interval form. So from minus infinity to minus 5, that is from all the way from here to this, not including minus 5. Okay. And all these values along with these values, that is 5 to infinity. So starting from 5 and it is going to infinity. Okay. But remember this pi and minus pi are not included. Okay. And that is why I have put a curved bracket over here. Okay. If it is included, you have to put a rectangular bracket. Okay. But it is not included. Right. So that is the meaning of modulus of x greater than 5. Now let us try to understand what is the meaning of modulus of x less than 3. Modulus of x less than 3 means, now you have to write the meaning of it. The meaning is x is a distance less than 3 from 0. So on a number line, a distance less than 3, okay, from 0 can be 2. Okay, this is one part. This is also a distance of 3 from the 0, and this is also a distance of 3 from the 0, isn't it? Only thing is this distance is on the right hand side and this distance is on the left hand side. Okay, but distance is never negative. Okay, so you have to take both these distances. So your x value will be between these two, minus 3 and 3, right? So x, modulus of x less than 3, the meaning is it will have all the values of x between minus 3 and 3, and again minus 3 and 3 will not be included. They will not be included, and that is why I have kept a hollow over here. This hollow circle is indicating that I have not included. In the interval form, I can write it in this way. Okay, curve bracket minus 3 comma plus 3. Minus 3 and plus 3 are not included. Okay, and this way also I can write minus 3 less than x less than 3, or you can say x is between minus 3 and 3. So modulus of x less than 3, the meaning is this. I hope you are getting it. Okay. Now these are the concepts of modulus and the meaning of the modulus that I am trying to make you understand. Let us go ahead with this. Modulus of x greater than equal to 7. Now what is the meaning of this? Again, because it is greater than, and you can see there's equal to sign also. So here in this case, the meaning will be x, that is whatever is inside the modulus sign. Okay, that x is a distance more than and equal to 7. See, this is greater than as well as equal to. So you have to say more than as well as equal to 7 from 0. Again, there will be two such things. The x will take two set of values, included 7 and greater than 7, and included minus 7 and less than minus 7. Okay, so this is greater than or equal to 7, x greater than or equal to 7, and this is x less than or equal to minus 7. So both these things are representing modulus of x greater than equal to 7. Okay, so the mathematical way of writing this will be modulus of x greater than equal to 7 means x is greater than equal to 7, that is from here I have taken, and or x is less than equal to minus 7, it's from here I have taken. Okay, so these are known as the solution of modulus of x greater than equal to 7. Okay, this is the solution. X greater than equal to 7, x less than equal to minus 7. On the number line, you can show the solution in this way. Okay, and inequality found, you can write the solution in this way. Okay, let us take one more. Modulus of x less than equal to 3. What is the meaning of this? Now, modulus of x is less than equal to 3. The meaning is x is a distance less than and equal to 3. See, here there is a less than as well as equal to sign. Can you see? These are less than and equal to, both sign are there. So here you will have less than also and equal also. Okay, and how much distance? This distance 3. From where? From 0. So this is my 0 on the number line. This is representing distance less than 3 including 3. Okay, less than 3 and 3 also. And this is also distance which is at 3 units from 0. Okay, so my answer or the solution for this inequality, modulus of x less than equal to 3, I can write this way. X less than equal to 3, that is this portion. This is x less than, equal to 3. And this is also there. So this I am going to write as x greater than equal to minus 3. See, this is x greater than equal to minus 3. Okay, so this and this both. I don't know why I written or every time. It should be and. Okay. So x less than equal to minus 3 and x greater than equal to minus 3. This is the solution. In the interval form, this can be written in this way. Now see, here I have purposely used a closed bracket, that is rectangular bracket. This rectangular bracket means this minus 3 and plus 3 both are included. And here see, I have shaded those circles. Okay, these are not hollow circles, right? So these two circles are shaded. That means this 3 and minus 3 is included in the solution, isn't it? Because of this less than equal to. So this can also be written as minus 3 less than equal to x less than equal to 3. Or you can say x is between 3 and x is between minus 3 and 3, including minus 3 and 3. Is that clear? So I think the meaning and the concept of modulus function and the meaning of modulus must be clear to you by now. Okay. Lastly, let me talk about the graph of a modulus function. Now, as I told you, y is equal to f of x is in general any function, okay, where x is the domain, y is the range of a function. And if this function is an absolute function, you can write this as y is equal to f absolute x. Y is equal to absolute x. Okay. Or it is many times written as y is equal to, between two parallel bars, you have to show this x. Okay. This both means the one and the same thing. This is y is absolute value of x. This is y is absolute value of x. There are two ways of showing it. Either you write abs and then in bracket you write x, or you just write x between two parallel bars. Okay, both are one and the same. So absolute function is denoted in this way. Now let us try to take some values of the domain, that is x. Now this is domain of the function, and if it is y equal to, so this is the range, right? So let us take some values of x as -3, -2, -1, 0, 1, 2, and 3. These are the values of x. Let this be y be the range. Okay, so what is the function? Function is y is equal to modulus of x. So if you take modulus of -3, it will be 3. Modulus of -2 will be 2. Modulus of -1 will be 1. Modulus of 0 will be 0. Modulus of 1 is 1. Modulus of 2 is 2. And modulus of 3 is 3. So I'm getting some values of domain and I'm getting the corresponding values of range. Now if I plot this point, that is -3 -3 plus 3, -2 plus 2, -1 plus 1, 0, 0, 1, 1, 2, 2, and 3, 3. If I plot these points, I will get this point. So this is 0, 0, this is 1, 1, this is 2, 2, this is 3, 3, this is -1, 1, this is -2, 2, and this is -3, 3. So all the 6 points I have plotted over here on this coordinate axis. And when I join these points, okay, to see what kind of a graph I'm getting, then I'm getting this blue color shape graph, okay, which is nothing but the graph of modulus of x. Okay, so this modulus of x in general will have a shape of a V, and the vertex of that V will always be at the origin. This is the graph of modulus of x. Y is equal to modulus of x. Now remember here, because in the next video I'll be going more deeper into it, but remember one thing, how you plotted this graph, this is the actual way of plotting it, but try to understand the concept. When they tell you plot a graph of y is equal to modulus of x, what you have to do is, inside this modulus sign between these two parallel bars, whatever is written, that particular thing, you draw the graph. Now here it is written x, so take y is equal to x and draw the graph of y is equal to x. Okay, what do you have to do? You have to draw the graph of what is written inside the modulus sign. Okay, so inside the modulus sign there is written x over here. So take that as y. So y is equal to x. Okay, so you will get this graph. Y is equal to x, it is a straight line passing through the origin and it is at 45 degree. Okay, this is y is equal to -x, right? Remember, this is y equal to x. So draw the graph of y is equal to y equal to x. Now what you do, because modulus of x can never be negative, so this particular part of the graph, this one, okay, this cannot be a part of the modulus of x graph. Okay, so this you remove from that. So y is equal to x ka graph is the whole line, this line, but modulus of x graph, if you want to plot, remove any part of the graph below the x-axis. So this is below x-axis, so that I will remove. But don't only remove it, you take a reflection of that particular part of the graph on the x-axis. So the reflection of this part of the graph on the x-axis will be this. So I have drawn this line. Okay. So this and this together will represent the modulus of x ka graph. This is the methodology and this is the way you have to understand how a graph is drawn. Are you understanding? So in this particular video, I just wanted to introduce you to what is modulus value or absolute value and what is the meaning of a modulus function and how to interpret a modulus function. Okay, it's not just mathematically that you should try to by heart things. Okay, you have to understand it as a statement. So I will summarize this entire session of today's into these 3 parts that you must understand. Modulus function is in general written as y is equal to modulus of x. Okay, this is what you have understood. Okay, and this is always having positive value. So the graph will always be above the x-axis. Okay, and you should understand very well what is the meaning of modulus of x equal to k, what is the meaning of modulus of x greater than k, and what is the meaning of modulus of x less than k. Okay, these three things, these three statements, if you understand the meaning, okay, you will understand this concept well, and further things in this particular modulus functions you will understand and you will be able to do things. Okay, so that is all for today's session. Okay, in the next video, video number 2, I will come with further deeper problems and meaning of this modulus function. Thank you for being with me. Bye.